Welcome, my name is David, and in this video I'm going to show you the blueprint code that supports the game that was demoed on the game trailer. Without further ado, let's jump into the gameplay. As you can see, we have very good game environment setting and setup character animation. You can see there is walk, run, and search. So in that case, we're able to find objects we need to complete the game. When the character is touching with collidable objects, a widget would appear to hint the player that the object is interactable. In here, I switch from our normal animation blueprint to a search animation blueprint, and then switch back. So the character could keep walking its walking animation when he finished searching. I have encountered problems if we do not switch back to its normal walking animation, then the character will just move in a parallel pattern, which looks really bad. Different hint could pop out since I have interacted with different objects. That could be simply accomplished by set binding to text and also destroy actor when searching. Now to the blueprints for a more precise explanation. A lot of code is in the third-person character blueprint. For instance, in here is some basic code that allows you to press shift to increase movement speed. Also, this could help construct the animation as well because we could play around speed variable that is an actual number. I learned how to do animation blueprints throughout this game design process. First, I have created a state that I named it Final State Automaton. Name does not matter, but this name feels cool, so I used it. In the state, you can see that I set up two states, which are idle and walk-run state, indicating we're switching from one state to another while taking different input. In the walk-run state, we have two variables that take in control. In the event graph, you could see that we get character's velocity and its rotation to determine its direction and speed. So the input of movement could affect our animation blueprint. And now I'm going to show you the blend shape I made to do the walk and run state. Let's jump into the blend shape in 1 second. So I created the blend shape so I could have a smooth transformation from walk to run. First, after we open the blend shape, named walk and run, we look at the left column. This is where we use speed and direction variables, make those two number factors that allows the character to idle and then walk in blend shape. See, we have direction and speed up at the left corner. And then next, move the green dot in the center of the screen. That is an indicator to give you a preview of how your speed and direction would affect the character model. Remember that we made our character run with shift at the beginning. That means when shift is pressed, the speed variable could change, and in this blend shape, I could transform the character from a walking state to a running state while the player press shift. When the green dot is moved to very bottom, that means the speed is set to 0, which is when the character is not taking any WSD movement input and stays there. So we have idle animation plugged in there. And let's take a moment to step back to the animation graph so we could check out state machine. We're about to see the translation control from idle to the walk-run state. If this is not checked, the compile button at the top left corner would remain a yellow exclamation mark that indicates us we have not set any conditions for the states. As we can see, it is a simple boolean, and when the requirements meet, it translates. In here, we set up speed as our condition. When the speed is greater than 10, we're starting to walk and run. And if it's less than 10, meaning we're coming to a stop. Very easy. Alright, let's head into another part of the main code, which I named surprise interaction. This part is the design when picked up some objects in the game. I set an integer variable called surprise number. When the collision happens, it has to third-person character and set its value accordingly. 500, 5,000, and 10,000. Taking our object the gift list as an example, we have an actor picking overlap destroyed upon picking up, and then set the number to 10,000 as you can see in the video. Collaborating with that, we have an interaction code section. In here, we have an actor variable named current collide. What this variable do is it could detect all detections and store its value. Then when we check for if this object is the correct collide object, it will be way easier. All the collides are listed here and stored into current collide when colliding. And with that, we have another lines of code, so when the character leaves the collision box, it will no longer trigger the collision and set current collide to nothing. Also, there's a boolean called isReady. It's the boolean that controls if you're able to interact with interactable objects in game. When we set it to false, the interactable would be disabled, but when it's true, the animation instance class, as you can see, will be set to search blueprints first. As you hold the E button, when we release, we set the animation instance class back to elf animation blueprint, which is the animation blueprint I made for idle walk and run. Note that there's a switch on in here. Different object collision will set this integer value to a different number as we interact with it. So we could have different events and we're able to set up correct events accordingly. For example, we have a door object and its event number is 0 when interact with it. So the notification text will be set to you need a key. And back to here, you could see the event number and set the boolean isReady turned on, so the objects are ready to be interacted. And let's take a quick moment to check out GameBase. And here we have 3 global Boolean variables that are presents. The goal of the game is to collect all presents and then escape the maze. It would be nice to have GameBase running and checking for winning conditions as the game moves on. From my perspective, what GameBase do is to provide variables that could be called in any blueprints. Third-person character blueprint could do the same. The difference is that one object says to get game instance and one object says to get player character. If you want to get to know more, check out the download link at my portfolio page. Thank you for watching and have a great day.